In this video, I'll be experimenting with several types of epoxy and will attempt to completely fill the grain of several pieces of red oak. While doing so, we'll look at different application methods such as using thin versus thick coats, using a pre-sealer such as shellac, and the differences in working in warm versus cold environments. I've got a couple of popular quick setting epoxies. This one is Gorilla Clear Epoxy, which has a 5-minute set time. And this is JB Weld Clear-Weld Epoxy, which also has a 5-minute set time. We'll try Z-poxy finishing resin, which has a 30-minute set time. And this Dave and Diana epoxy resin is my budget pick at $10 on Amazon, and it's also a 30-minute epoxy. We'll also try another Z-poxy product, which is their 30-minute epoxy, and we'll see how this differs from their finishing resin. I've got a nice piece of red oak here, and this board has all kinds of pores and grain to be filled, so there's no doubt that it will present a nice challenge. To prepare, I cut the board into 8-inch pieces and sanded each piece to 320 grit. I then sealed half of each piece with shellac to see what effect sealing might have. I used a 3/4 pound cut shellac, and I applied 6 coats total, sanding with 320 grit after every 2 coats. Now we're ready for the epoxy. We'll start first with the Z-poxy finishing resin by mixing equal parts of the resin and the hardener. This is a low viscosity epoxy, but it's mixing a little thicker right now because the temperature in the garage is about 50 degrees Fahrenheit, which is at the lower limit of the acceptable temperature range. I did use a warm water bath to warm up the mixtures, and I'll also bring the boards inside to cure in a warm environment. But after this series of comparisons, I'll do another set inside at 70 degrees and add a couple more application comparisons as well. I probably should have put a little bit more on this piece of wood, but as you will see, a little goes a long way, and this amount actually seems sufficient to coat the surface of this piece. My goal in this first set of comparisons is to apply as thin of a coat as possible and see how many coats are needed to completely fill the grain. And I also want to learn about the sanding properties of different epoxies and how easy or difficult they are to work with as a grain filler. After working it into the grain, I'll use a plastic card to scrape away the excess. I found some blank plastic ID cards on Amazon that work really well, as they are flexible and have rounded corners. So I'm going to scrape away as much as I can, trying to leave a very thin coat of epoxy so as to eliminate as much sanding as possible after it cures. So we'll let this dry and cure inside where it's warm for about 24 hours. Next, we'll try the Dave and Diana epoxy resin. This was the cheapest of the bunch at $10 for 16 ounces of epoxy. That's 8 ounces of the resin and 8 ounces of the hardener. In contrast, the Z-poxy finishing resin was almost $29 for 12 ounces. The epoxy mix is clear, unlike the previous Z-poxy finishing resin, which had a slight amber cast during the mixing. They both spread very smoothly and are easy to work with, however, especially given that they have a 30-minute working time if needed. Now this one's ready to dry for 24 hours before sanding. This is the Z-poxy 30-minute epoxy, which is marketed more like an adhesive or a bonding epoxy, as the branding touts its extra strength and permanent bonding properties. I paid about $15.50 for 8 ounces, which is 4 ounces of resin and 4 ounces of hardener. And right off the bat, I can tell the consistency is more thick than the finishing resins that we tested earlier. It takes a bit more effort to spread over the workspace, but it's not a big deal. It also seems to coat a bit thicker, so it'll be interesting to see how it sands. It even looks like it coats a little bit thicker than the finishing resin. And you can tell it takes a little bit more effort to scrape off the excess. But as I mentioned earlier, you'll see in the next round of experiments that the temperature does significantly affect the consistency and the pliability of all of these epoxies. And this one's ready to dry. The Gorilla Clear Epoxy has a 5-minute set time, and it also seems pretty thick in comparison to the finishing resins. The mixing time for this one is only about 20 seconds. And I also dipped this cup into the hot water bath to try to lower the viscosity a little bit. Just because it's so cold in the garage right now, it's right at 50 degrees, maybe a little bit below. These 5-minute epoxies take a little more effort to spread around the surface, and I can tell that I have to work a little more quickly as it is becoming more and more sticky by the second. It's been more challenging to get a thin and even coating with this one so far, although that might be partially due to the cold environment, and you'll see in a later test that that is in fact the case. And that's about as thin as I could get it. It still looks like a pretty thick coat. And the JB Weld Clear-Weld epoxy seemed very similar to the Gorilla epoxy. Both have 5-minute set times, and both are pretty thick and a bit more challenging to spread evenly on the surface. These 5-minute epoxies would be easier to work with in warmer climates. Even though I tried to warm up the mixing cups while I was mixing them, the surface of the wood was still kind of cold, and I think that contributed to the difficulty I was having spreading the epoxy over the surface, although it really wasn't that bad. And again, like the Gorilla epoxy, this left a pretty thick coat. And here are the results after the epoxy dried for 24 hours. Remember that the right side of these boards were sealed with shellac, and you can see that the epoxy seems to be standing on the surface more on the right, and that it was absorbed more into the wood on the left. The right sides are more glossy and reflective. The 5-minute epoxies went on so thick that it almost looks like there's not as much difference between the right and the left, although if you look closely you can tell that there was more absorption on the left unsealed sides. So I'm going to start sanding these boards by hand using 320 grit sandpaper just to see how the dried epoxy responds and how much effort is needed. Normally I'd just pull out the orbital sander with some 220 grit paper and be done with it, but I'm curious about the nuances of sanding these epoxies. And the Z-poxy finishing resin responded pretty well to the 320 grit sandpaper, which is nice because it's advertised as being easy to sand. Next up is the Dave and Diana Crystal Clear Epoxy Resin, and it also responded quite well to the 320 grit sandpaper. So far, both the Z-poxy finishing resin and this one have responded more like a finishing material than a glue, in my opinion. The Z-poxy 30-minute epoxy, on the other hand, took a bit more muscle and effort to sand with the 320 grit. And you can see here that there are numerous shiny areas and missed spots after spending a good amount of time with the 320. So I eventually dropped down to a 220 grit paper to finish the job. For the Gorilla Clear epoxy, I went straight to the 220 grit, and it still took a little extra effort, but again, with an orbital sander, it would have been fine. And to me, it sounds like these last couple of boards with the thicker epoxies sound a little more filled than the first two boards that we tested at this point. With the JB Weld Clear-Weld, I started with a 320 grit, which proved to be a bit too fine, so it didn't take long to switch to the 220 grit, and it responded almost exactly like the Gorilla epoxy did with the 220. And here's a look at all the pieces sanded to 320 and ready for the next coat. It's interesting that it's hard to tell which side was sealed with shellac at this point. And so we'll begin round 2 and go in the same order, starting with Z-poxy finishing resin. And I'll try to edit through this round of application fairly quickly. Here's the second coat of the Dave and Diana Crystal Clear Epoxy. Followed by the second coat of the Z-poxy 30-minute epoxy. Here's the second coat of the Gorilla 5-minute clear epoxy. And finally, the second coat of the JB Weld Clear-Weld epoxy, which is also a 5-minute epoxy. And here are the results after the second coat of epoxy has dried for about 24 hours. Notice that it has become more difficult to determine where we applied this shellac sealer, which was on the right side of all these boards. It'll be interesting to see what we're left with after sanding all of these back down to wood. And again, I'm going to use the 320 grit sandpaper on this Z-poxy finishing resin. I'll do the same thing with the Dave and Diana and sand it down with a 320 grit sandpaper. I also used the 320 grit sandpaper with the Z-poxy 30-minute epoxy. And although I got good results, it did take longer than the previous two examples. I started out using the 320 grit sandpaper on the Gorilla Clear 5-minute epoxy, but after some hard sanding it still left quite a bit behind, and eventually I just used 220 grit and an orbital sander to finish up. And on the JB Weld Clear-Weld board, I just went straight for the 220, and in fact, I ended up going to the 220 on the orbital sander to finish this up as well. So I went back and cleaned everything up with the orbital sander and also with the 320 grit sandpaper, and I think we're ready for some finish. All of these sound pretty smooth and filled, but I'm skeptical because it usually takes me about 3 coats to completely fill the grain on oak. So I masked off half of each board and applied about 7 coats of 1-pound cut shellac to each one. And at first glance, they all look pretty good. And for all intents and purposes, it seems like 2 coats of epoxy was enough to fill the grain with all of these, which surprises me because usually it takes me about 3 coats of epoxy to get to this point. I wonder if mixing these epoxies in cold temperatures resulted in a thicker application, thus allowing for more product to be filling the surface of the boards. Then the mixtures might have expanded even more while drying in a warm environment. But looking more closely at a different angle to the light, I think that I can see some areas where the grain appears to be popping through, although it could be the result of my rather haphazard finishing technique with the shellac. So I'm going to try this experiment again for a couple reasons. I would like to apply the epoxy in an environment that is 70 degrees Fahrenheit, which is more within the recommended range of temperatures for these products. And I also want to experiment with applying coats of different thicknesses to see what effect, if any, that they might have on grain filling and sanding. So I've moved indoors to a room that's a little over 70 degrees, and it becomes immediately apparent that the Z-poxy finishing resin is a low viscosity epoxy, as it actually dripped off the board while spreading it around and scraping it off. This makes it possible to get a super thin coat with ease. The same held true with the Dave and Diana. It's a super low viscosity epoxy and easy to apply in thin coats. The Z-poxy 30-minute epoxy was also easier to apply, and this was actually a nice consistency because it didn't drip or run. I decided to use just one of the 5-minute epoxies since they were so similar, and this Gorilla epoxy went on nicely as well. This is a huge difference from applying it at 50 degrees. It's actually nice to work with the exception of having a short set time. To experiment with application thickness, I went back to Z-poxy finishing resin and applied it liberally and left a nice thick coat on this board, which also happens to have a crack running along the bottom of it. And here we are with the results after the first round of coats applied indoors. Remember that the right side of each of these boards has been sealed with shellac, and again you can see where the epoxy has been absorbed more into the wood on the left sides. I was able to apply thinner coats this time around since the warmer temperatures lowered the working viscosity of the epoxies, with the exception of this one where I intentionally applied a thick coat. Here's a close-up of the thick and thin coat comparison using the Z-poxy finishing resin. Just like before, I sanded everything down to 320 grit to prepare for the second coat of epoxy. At this point, after sanding both down to wood, the thin coat and the thick coat fill look about the same. And here we go with coat number 2. This is the Z-poxy finishing resin, and I'll be applying a thin coat to this board, scraping as much off as I possibly can. And this is the board that will be receiving a thick coat of the Z-poxy finishing resin. Coat number 2. Here are both boards of the coat thickness experiment side by side after applying the second coat. Next is the second coat of the Dave and Diana 30-minute epoxy resin. Followed by coat number 2 of the Z-poxy 30-minute epoxy. And finally, the second coat of the Gorilla Clear 5-minute epoxy. Here are the results after letting the second coat dry for 24 hours. It seems to me that these coats applied indoors appear to be a lot thinner than the ones that were applied when I was in the cold garage. After I finish showing these results, I'll show a clip of the boards we coated earlier during the first round in the cold. So here's the flashback to those boards that we coated during the first round in the garage. The second coat on these almost looked goopy and uneven in comparison. Once again, I sanded everything down to wood with 320 grit sandpaper in preparation for more finish. At this point, I'm going to test the boards with a shellac finish. So I masked off half of each piece and applied several coats of shellac. And in case you saw my shellac solvent video, I'm using the shellac that I made with the 91% isopropyl alcohol for all of the finishing in this video. The Z-poxy and the Dave and Diana still showed grain, but you can also tell that the areas that were shellacked on the right sides of the boards were filled in just a little bit better. The grain showing here really didn't surprise me because of how thin of a coat I was able to get on these boards in the warm environment. The Z-poxy 30-minute epoxy seemed to fill the grain, as did the Gorilla Clear 5-minute epoxy, which makes sense because they are both inherently thicker formulas than the finishing resins. And the thick application of the Z-poxy finishing resin was also a success after 2 coats. Although it's interesting that I can barely see some air bubbles left behind here on the thickly coated board. Here are the thick and thin coatings of the Z-poxy finishing resin side by side. The shellacked portion of the thin coat board actually looks pretty good. And the heavily coated board also looks pretty good. Some air bubbles did make their mark, however, on the side that did not receive the shellac. So at this point, we've got 2 epoxy finishing resin boards still showing grain after 2 coats of epoxy, the Dave and Diana and the Z-poxy finishing resin. So I decided just to add another coat of epoxy across the entire surface of both boards without sanding or any further preparation. This is the Dave and Diana board. And this is immediately after applying the third coat of epoxy to each of these boards. I then sanded everything down to 320 again, applied shellac to the entire surface of the boards the same way we did before, and it seems like the third coat of epoxy on these boards was able to fill the grain. So purely in terms of grain filling, all of these epoxies prove to be comparable with getting the job done. The main differences are in the pliability, the set time, and the ease of sanding. Actually, they all sanded better than I thought they would, especially the finishing resins. Even though the 5-minute epoxy did a fine job at grain filling these small pieces, I would imagine that their fast set time could cause problems for larger projects. And I can see how the low viscosity epoxy resins could prove more versatile and have a broader scope of applications, including even being able to be used as a finish by themselves. They were all fun to work with, and I can imagine that using some of the commercial grade epoxy resins out there could be a fun experiment as well. So maybe next I'll try finishing or gap filling with some of these epoxies, or maybe some other epoxies out there.